Hi, in this session we're going to cover how we can use a single sign-on solution for our PowerServer apps and for based. So first we have a legal disclaimer. Let's go over the agenda. First I'm going to tell you who I am, just in case you don't know who I am. Then we're going to look at what it takes to enable OAuth in our PowerServer project. Then we're going to look at see what we have to do in our PowerBuilder client code to do the OAuth calls to PowerServer. And then finally, we're going to look at some configuration that we'll need to do in the Web API C# code for OAuth. I'll do a demo of how that works. Then we're going to look at a React Native client that I've written. I'm going to show you how you need to configure cores in the Web API C# code. You may not need to do it depending on who your client is, but because I'm testing my React Native client in a web browser and it's running in a web server, it triggers a cross-origin call, and so I'll need to have cores configured in the Web API C# code in order for it to actually respond to the request. And then I'll have a demo of the React Native client, and then we'll have Q&A. Now, a bit about me. My name is Bruce Armstrong. I work for a company called Integrated Data Services. I've been using PowerBuilder for a real long time, since version 1. I'm familiar with a few other languages, and I've listed them there. I'm also involved in a couple of open source projects related to PowerBuilder. I'll learn a little bit about the company I work for, and let's talk about OAuth. Now, I have an earlier session where I discussed how to implement a numerous methods of authentication in PowerBuilder. JWT, OAuth, Cognito, Amazon's Cognito, Microsoft's Azure AD. This is going to be a repeat of the OAuth section of that session. And so if you did see that session before, I just ask you to bear with me. But for completeness, I want to show how we're going to implement OAuth on the PowerBuilder side. So what happens with OAuth is PowerServer comes with an OAuth server, and you just turn that server on. And then what happens is you configure the client to send a token request to the OAuth server in PowerServer. If the user logs in correctly, they'll get back a OAuth token. You take that token and you apply it to there's actually an application setting you can enable that then just uses that token on all subsequent HTTP requests. So the data request is then sent with that token. The Web API gets that token, validates it against the OAuth server. And if it gets a validation, it says, okay, I'll go get the data, return the data, and then return the data to the client. So that's the flow. What I also want to point out is I'm using OAuth as an example here. All the various options that I referred to in my previous session, JWT, OAuth, Azure, AD, or Amazon Cognito, it'll all pretty much apply. The specifics about how you do the actual API call will vary between them, but most of what we're going to cover is going to work regardless of which authentication authority you're using. So let's look at what we need to do in the PowerServer project to support OAuth. The first thing you do is you go to the Web API tab of your PowerServer project, and there's an auth template section here, and there's a drop down. There's a number of options there. What we want to select is the Use Built-in OAuth server. Then on the Runtime tab, because the client is going to have to make an OAuth request, we are going to check the OAuth 2.0 support, and also because we're enabling compression, we need to have compression support checked. Then we're going to open up the application object, click on the Additional Properties tab. There's a PowerServer tab on that Additional Properties, and there's an option there for begin session by code, and we want to check that. Normally what happens if you're not using third-party authentication is that the session's automatically started. What we want to do here is delay the creation of the session until after we've authenticated and then start the session. In my demo code, I've got some instance variables here. You ignore these down here. This is for my previous demo where I showed all the different approaches. So we can just ignore that. But what we're going to look for here is this an instance variable that keeps track of when the token expires. So when you do get a token for the OAuth server, it's only going to be valid for a certain amount of time. And you want to track that and request a new token before it expires. And we're going to show how you do that here. The other thing here is what's called a clock skew. What this does is it accounts for the fact that the time on the server that's generating the tokens and the time on your client that's trying to use the tokens may not have the exact same time. And so what the clock skew does is says, this is how many seconds before the token expires that I'm actually going to send my refresh token request. This is a PFC-based app, and so the user password is actually already stored. The user ID is actually already stored in an instance variable, but I want to save off the password as well, because we're going to need to use that when we do the refresh of the token. Now what I want to do while I'm still in the application object is click on the insert. Let me zoom in here a bit. Click on the insert at the top, select object, and then timing. So we want to create a timing object as a property of the application object. Then this is in the timer event for that timing object. Oh, sorry, too far. What we want to do, we just want to call whatever our authentication process is. Once again, this is from the demo where I was showing all the various methods. You wouldn't be doing this in a real app. You just have one authentication method, and what we would want to do is call that authentication when the timer expires, because this timer is going to fire based on the expiration date of the token minus your clock skew. So here's the start session method, and we end up calling this a little bit later. So what it does, this is where we take the application object and we call a begin session method on it, which will actually begin our session. And then down here, we see if we've got an expiration date on our token. And if we do, we subtract off the clock skew. And then we set the timing object. This is the name of my timing object, to start in the expiration date of the expiration time of the it gives you a number of seconds. So it's the number of seconds that before the token expires minus the clock skew. So the timer event will fire before the token expires and will request another token. This is the system error event for the application. Once again, this is a PFC app, so I've this is part of the application object or the application manager. There's some new error codes that have been added for this third-party authentication. So you can see session error, license error, token error. You get a token error. What you can do is recall your authentication method once again. This is my demo code where I was using all the different approaches. You would just call whatever your individual authentication method is. Here it would be OAuth. This is my PFC login event, and one of the things I'm doing here is I checked to see if it was a PowerServer app. That way I could maintain a single code base and do both client-server applications and the PowerServer applications. So down below, in the else clause, it does a standard database login. Now what I'm doing, and once again this is because my sample code was doing all the different authentication methods, is I actually check the application INI file to see which authentication method I want to use. So you wouldn't have that in your app. And you wouldn't have a choose case based on the authentication method. You would just call your OAuth authentication. If the authentication works, then you call that start session method that we just looked at. This is just my INI file. So the only thing I'm reading here is which authentication type I'm using, and once again, you wouldn't do that in your app. You would just use one. And then the URLs where we request the token. And for JWT, OAuth, Incognito, it actually is the same one. I left them separate just for, I don't know, just to maintain the option. Okay, so this is how we actually do the authentication. This would be the OAuth authentication method that was referenced earlier. So we're going to create a token request. We're going to take that URL we just read out of the INI file, or you would, perhaps hard code this, either way. You're going to do a post. You're going to send client ID of RO client. You're going to create a client secret and go ahead and use that here. And later we're actually going to configure the PowerServer, actually the Web API C# code to have that same client secret. The scope is Server API. Grant type is password, and then you take the username and password that the user gave you and pass that in for username and password. Create an OAuth client, ask for an access token, and then check to see if you actually got an access token. And if you did, grab the expiration, the number of seconds until it expires. Okay, we got to make some changes now in the Web API C# code because we have to authenticate the user somehow. And I'm going to zoom in here a little bit. There's a couple files here. There's an authentications extension, which is what you're looking at here, and it's got some blocks here where we'll call either database user store or default user store. What default user store is, it has a hard-coded list of usernames and passwords, and it just looks to see if the username and password that were provided are on that list. Now that's not something you really want to use in a production system. We actually are going to use that here. I just put a couple users in there. And I'm going to go ahead and use the default user store. The database user store is where you would actually interact with the database to determine whether or not the user's password is username and password are valid. Now, there's a couple of different approaches you might use there. The brute force way would actually be try to log the user in using their username and password and catch the exception if it doesn't work. That's not very performant, and you would hopefully want to get away eventually from using actual database accounts to validate the user. So what you might migrate to is putting a table in your application that has a list of the users and their encrypted password, and then you would retrieve that in your database user store, decrypt the password from the database, and compare it to the password that the user passed in, and validate the user that way. So what this file does, the one that's shown here, is you can see right here, we do the add singleton, and we say default user store, or if you wanted to use the database user store, you would comment that out and uncomment this one and use the database user store instead. But you're going to have to add something to the database user store to actually authenticate your users. It's just a template right now. This is just everything we just said. Okay, so let's go ahead and take a look at how this works with PowerServer and the PowerBuilder client. Okay, so this is our PowerServer project. You can see that I'm using the OAuth server. I've actually gone ahead and run it in the background here. I'm going to go ahead and fire up the client and log in. And there's the app. Now, just to show that I actually did log in, I'll bring up Fiddler here, and we can look right there. There's the authentication request. There's the basic auth. There's the pass name, user pass name. Username and password, the scope, and the grant type, and then there's our access token coming back. In fact, you look at it in JSON, and there's that expires in I was talking about earlier. So this is good for, I can't do the math off the top of my head. An hour maybe? I don't know. Somebody can correct me later. Anyway, that's what the PowerBuilder client looks like. So let's go ahead and look at the native client I've created. So I'm doing this in React Native. And main thing you want to see here, if you remember the parameters we were passing to the token request in PowerScript, we're basically doing the same thing here. I've got a set of parameters, username, password, the server API scope, RO client for the ID, the client secret, and grant type password. And then what I do is I just loop through the parameters and URL encode them, and then put them together. This basically forms the form body. Well, that's why it's called form body. It's the HTML expression of a form request. Then I'm going to access the same port that the PowerBuilder client does. I'm also going to do a post. Here's that type, the type that the data was formatted into, which is www form URL encoded. And then just send off the request and check for to make sure I got a success message. The one thing I'll note here, if you heard me talk about OAuth request before, is what PowerBuilder does, and what I've mentioned previously, what you should have here, is also a authentication header, which has the client ID followed by a colon, followed by a client secret, and then that's base64 encoded. The reason I don't have that here is you'll look at here and you'll notice that I am actually sending the client ID and client secret in the body. And as it turns out, in the OAuth spec, that's a choice. You can either send it in the basic authentication request, or you can send it in the body. What really matters is which one of those the server that you're talking to supports. As it turns out, the OAuth server that's packaged with PowerServer supports both. And so the PowerBuilder client is going to go ahead and use basic auth, but for my React Native client, I'm going to go ahead and include it in the body and not have an auth header. Now the reason I did that is I'm trying to avoid something that's called cores. And I may remember that being one of the slide titles. And for the most part, or for about half of it, I did manage to avoid cores. We'll get into it in a minute, what cores does, but I was trying to avoid triggering cores. And I did it for the request, but cores still got triggered for the response, and so we have to do something about that. And here it is, cross-origin sharing standard cores. So it's triggered when one web server makes a request to another web server. And by web server, it can mean the domain is different, the subdomain is different, or even that the port is different. And so when I show you the demo here, you're going to see that that the PowerServer, the web API code, is running on localhost 5000. My React Native app is running in a web server it's also on localhost, it's just on a different port. But that triggers the cross-origin sharing standard. And it has a number of implications. Now, at least on the request, what you can do to avoid triggering cores is to make sure you're only doing get, head, or post. And so we're doing a post, so we're fine there. You need to limit the headers to accept language, content language, and content type. And if it's content type, there's only 3 content types that are allowed. The www form URL encoded, which we're using, multi-part form data, and text plain. Notice JSON is not on that list. So we're actually fine as long as I didn't put in the authentication header. What was happening, and we'll go into more into cores here and you'll see what was happening. If you don't meet those standards, let's say if I put in my authentication header, what that would do is that would cause the browser to send not your post request, but an options call to the server first. And only if the options server call works does it actually send the post request. And what was happening is that the web API was getting this options call and was saying that's not an allowed method, and the call was failing. So by removing the basic authentication header, I was able to make sure that it only sent the post request, and my request was getting through. The problem still, though, is Chrome, where I'm running this, was pretty smart, and it recognized that this was still a CORS call. And so when it got the response back, it was looking for an access control allow origin header that indicated what origin was allowed to call that server. It didn't get that header, and so it was blocking the response back to my client. And so that's where we need to tweak the C# code a little bit. Notice you can also, what the access control allow origin does is allow you to specify which origins, which websites are allowed to call your service. And you can also place controls on the methods and headers that can be sent as well. Just want to mention that. So this is what we changed. It's a minor change. In the default config file in your C# project, there's the creation of the client. And down in the creation of the client, you just add this line, allowed cores origins, and you put in the origin of the website you're making the calls from. Now notice that there's no backslash, there's no trailing backslash on that. A backslash is a URL or a domain. This is an origin. It doesn't have the backslash on the end. So this will accept now calls from my web, my React client running in a browser, at least on the browser I'm running in. I also mentioned earlier that there was a spot where we configured the secret that both the server and the client are using, and I forgot to show that, but that's right here. That's in that same client constructor. So there's the secret. So you could always change that and change your clients if you thought that the secret had been compromised for some reason, like it got showed in a demo like this. Okay. So let's go ahead and take a look at the React Native client. Okay, so this is my React Native client, and as I indicated, it's not terribly complex. This is that login screen. There's more to it than that actually showed, but there's the login section right here that I did show in the presentation. The rest of it's just controls, and then if that works, it just takes you to a page that says welcome and log out. So not a whole lot to it. There's the web APIs running in the background. This is a tool called Expo. It's really nice for when you're working with REST Native. You can preview it in a browser. That's what my app looks like in the browser right there. You can run it on an iOS emulator, on Android emulator. They've got a client app you can run in your clients, and then you scan this barcode, and it goes ahead and runs the app on your local device. So anyway, this is the app. This isn't going to be too impressive, except that it just shows that I can log in using the same username and password that I used for the PowerServer client. And I've got just to show that it actually was doing something there. I've got Fiddler running here in the background, so you can actually see. No smoke and mirrors here. This was actually an OAuth request. There's the form www form URL encoded data right there, and there's the access token coming back from the web API. Okay, and that takes us to questions and answers.